Module 5 Colpitts Oscillator. The Colpitts oscillator uses a combination of inductor and capacitor to generate a stable sinusoidal signal. The applications of this particular oscillator includes RF applications, signal generation, and frequency synthesis. And the advantages includes simplicity, stability, and ease of implementation. The figure shows the circuit of a Colpitts oscillator. The frequency of this oscillator can be calculated using the formula 1 by 2 pi root of LCT, where CT represents total capacitance, that is equal to C1 into C2 divided by C1 plus C2. The key components of this oscillator includes inductor, capacitor, and active device. Inductor is responsible for storing energy in the form of magnetic field. Capacitors, we are using two capacitors C1 and C2, and these capacitors along with the inductor form a resonance circuit which will determine the frequency of oscillation. Active device. It can be a transistor or an op-amp, and the active device amplifies the signal and provides the necessary feedback to sustain oscillations. The basic Colpitts oscillator can be constructed with an NPN transistor in a common emitter configuration. The inductor N connected between collector and supply voltage. Capacitors, two capacitors. C1 connects the base to the emitter and C2 connects the base to collector. Active element. It provides gain and amplifies the signal. As I have explained earlier, it enables positive feedback necessary to sustain the oscillations. And the feedback network determines the frequency of oscillation. The configuration of the transistor amplifier is of a common emitter amplifier with an output signal 180 degree out of phase with regard to the input signal. And the two capacitors in series will provide another 180 degree phase shift, and the total or the overall phase shift of the circuit will be 360 degree. The amount of feedback developed by the Colpitts oscillator is based on the capacitance ratio C1 and C2, and it governs the excitation of the oscillator. This ratio we can call it as feedback fraction.